Number 23, this one is a simple one here. We have the absolute value of x is less than 8. So I don't think we've seen very many, but there's two scenarios that we have here. If we have x, absolute value of x, let's say it's greater than some number, I'll just say a, this translates to x less than negative a. So you flip the symbol, flip the sign. This is supposed to be an a, not an 8. A. Or we have x is greater than a. So you got to do the positive and the negative. You drop the absolute value, and then you flip, and you get this. So if it's greater than, these are the two scenarios. However, you could also have absolute value of x is less than a, some number a. And if that's the case, that translates to negative a less than x less than positive a. So you have the inside. So depending on what case you get, you have one of these scenarios. Ours looks like this. So we're going to just translate that to this. That's just the rule. So we have a negative 8 less than x less than 8, positive 8. And that's all you have to do there. You could also, just write it out like we would normally do once you have this set by itself. Thinking about solving it twice, you can get x is, let's just flip it, greater than negative 8. And then you have x less than positive 8. So that's just dropping and leaving it the same. And this is flipping the sign, but when you flip that sign, you got to flip this. Now, when you put this on a number line, what you see, we have negative 8 over here, and we have positive 8 over here. X being on the left, this is pointing you to the right. So that means we're going from negative 8 this way. But when you get to positive 8, it's saying, okay, the x values are going that way. So you get this scenario where you're in between the two positive 8s. So that's why we have this scenario here. And even if you did that with interval, you would have negative 8 to positive 8. And so that's the same way that you would write that in interval notation or set notation if you want to put the set there. So the answer that we want here is going to be C. Number 24. X minus 2 over x minus 5, x plus 6 over x minus 7. Okay, so we're going to cross multiply when we have two fractions. We're going to bring this one and multiply it over here. We're going to bring this one and multiply it over here. So I'm going to have x minus 2 times x minus 7 equals x minus 5 times x plus 6. Now, one thing to note, doesn't pop up all the time, but you do need to be aware. Since this was originally a division problem, you have to keep in mind that we're dividing by x minus 5. If we plug a 5 here, we have 5 minus 5, we're dividing by 0. X cannot be 5 because that would make the bottom 0. Same thing here, x cannot be 7 because 7 minus 7 is 0. So x cannot be 5 or 7. If one of these showed up as an answer, we couldn't use it. Something that we forget to talk about or mention, but it's very important that you do note that you have some restrictions. You cannot use 5 or 7 because you would divide by 0, and that would not work. All right, so let's distribute and solve. So x times x will give us x squared. X times negative 7, negative 7x, negative 2 times x, negative 2x, negative 2 times negative 7, positive 14. X times x, x squared, negative 5, x times positive 6, positive 6x, negative 5 times x, negative 5x, and then negative 5 times 6, negative 30. All right, we're going to simplify. X squared minus 9x plus 14. And we have x squared. That'll be plus x when you simplify minus 30. All right, so they both have x squared. So if I subtract x squared, these two will cancel out. And from here, we're going to solve for x. So I want it to be positive. So I'm going to add 9x. So I can deal with positive. That's going to cancel. And then since I moved the x here, I'm going to move the number over here. So I'm going to add 30. So that 30 is going to cancel. So 14 and 30 will give us 44 equal 10x. Divide by 10. And that will reduce. Both of these are even. So we can reduce this to 22 over 5 equals x. 22 over 5. Looks like answer choice A.